Solids can come in many different shapes or sizes. For example, this pen that I used for the intro of this video is considered to be a solid. This golf ball, or this spherical object, is a solid. And this cool looking toy car is also considered to be a solid. Now the question that we want to answer is why? Why are all three of these objects, the pen, the golf ball, and the toy car, all considered to be solids? Now we can answer this question of why by looking beyond the surface of the solid and beyond the physical characteristics, and we can look at the atomic level and how those atoms of a solid are structured. If I were to draw a pictorial representation of the particles within this solid, I would draw these atoms super close together and super compacted, leaving very little room in between them. Okay, this is because of the strong attraction each one of these atoms have for one another. In fact, you could consider these atoms of a solid as best friends. Okay, they love each other. They want to be as close as they can to each other, leaving very little room in between them. Another comparison that you could make between the atoms within a solid is a concert. At a concert, everyone is packed into the arena, the music is loud, people are shoulder to shoulder, and there's very little room or very little space in between each person. This tightly packed orientation of atoms within a solid is why solids are so structurally sound. These atoms within this block prevent me from putting my fingers right through it. It explains why I'm able to use this pen and hold this pen in my hand and use it to write. And most importantly, my golf ball won't crumble to pieces when I'm putting in for birdie. Now that we know that the particles of a solid are tightly packed together, let's take a look at how this impacts the shape and the volume of a solid. If I were to find the volume of a solid, I would need to do some quick math, some quick measurements. To do this, let's first find the length of this solid. And doing that, we get a measurement of about 9.5 centimeters. The width of this solid, I'd say, is about 7, and the height of this solid is about 1 centimeter. So if we do length times width times height, we get a volume of 66.5 cubic centimeters. Now, if I were to place this solid block into an empty beaker, what do we notice about the volume? Did the volume of this shape ever change? Okay, the answer to that is no. The volume is still at 66.5 cubic centimeters. So because the volume did not change, we can say that the volume of a solid is fixed. It does not change when you put it into a new container. What about the shape? Well, let's see. Outside of the beaker, it's rectangular. Inside of the beaker, it still contains its rectangular shape. So we can also say that the shape of a solid is fixed. It does not change. So solids have tightly compacted particles, it has a fixed shape, and it has a fixed volume. Moving on to the second state of matter, liquids. Now again, we have the same question of why. Why is water considered to be a liquid? Well, let's go back to the drawing I made regarding the atomic particles of a solid. With a solid, the particles are tightly compacted together, they have strong attraction force between one another, and there's very little room between each one. And again, we said that they were best friends. Now, for liquids, it's going to be a tiny bit different. Because the attraction of the atoms within a liquid are not as strong, the particles tend to spread out and leave room for one another. We can compare this to let's say a family reunion. Family reunion. In a family reunion, everyone there knows each other. and everyone there likes each other, but no one is best friends with anyone or super close, and they tend to enjoy their space. This loosely packed orientation of these particles is why we are able to pour liquids and why liquids flow. So the particles of a liquid are more spread out and not as compacted. And just as we did with the solid, let's see how this arrangement of particles impacts the shape and the volume of a liquid. To test the volume, I'm going to start with 50 milliliters of water in this beaker. If I pour this water from the beaker into the graduated cylinder, what's going to happen to the volume? Let's find out. Did the volume change any? The answer to that is no. I started with 50 milliliters into the beaker, and we ended up with 50 milliliters in the graduated cylinder. So we could conclude that the volume of a liquid is fixed. It does not change. What about the shape? Well, I have 3 different containers, all with different shapes. If I pour this water into each one of these shapes, what's going to happen to the shape of the liquid? Let's see. Did the shape change? Yes, the shape did change. So we can say that the shape of a liquid is not fixed. It will change when you pour it into different containers. So liquids, spaced out particles, or loosely packed particles, think of it like a family reunion. The shape is not fixed, meaning the shape will change, but the volume is fixed. The volume does not change. Moving on to the third state of matter, gas. Can you guess how the particles of gas are arranged? If you said spread out, then you are correct. Gas particles have little to no attraction to one another, and they leave large amounts of space between each particle. You can compare the particles of a gas, or the atoms of a gas, to strangers at a coffee shop. Strangers. No one knows each other, no one really cares about each other, and all they want to do is just get their coffee and go sit down. So we have spread out particles. But how does the arrangement of these atoms, or of these particles, impact the shape and the volume of a gas? Well, one thing about gases is because the particles are so spread out, we can consider them to be compressible. Oxygen tanks that divers use is a good example of gases being compressed into a new container. So what would happen to the shape and the volume? Well, just like liquids, the gas's shape is not fixed. It's going to change its shape based on what container it gets put in. But unlike liquids and solids, the volume of a gas is also not fixed. It will too change. So with the gas, we have spread out particles. They're strangers in a coffee shop. Their shape is not fixed. It's going to change. And their volume is also not fixed. It will change. Now, some of you may be asking, wait, isn't there a fourth state of matter called plasma? Well, there is, but I'll have to save that for another video.